Hi everyone, this is 3D Printing News Unpeeled live with yours Peels. And thank you for joining me once again while we go through the important 3D printing news of the day. And today we're going to be discussing a couple of things that's showing really the breadth of our industry, really. So we've got 6 news items, and the first one is Stakeholder Foods introduces the Omekase Beef Bites. So Stakeholder Foods is a hard-charging, very aggressive, quickly conquering the market Israeli company who are trying to bring cultured meat to your plate. And they are making, well, they've now introduced Omekase Beef Bites. This is an obvious attempt at going after the Wagyu market, which is to many people the most coveted steak. And they're trying to make a kind of more ethical, less water use, no animal killing, less land use kind of alternative to this, which can have very, very high impact, of course. And as you may notice, the cost of a lot of things is going up, including an accelerated rate out of meat. So this could find a very wide, very big market that could have really considerable impact on the world. They're now making kind of beef bites, kind of like a bonbon of beef or something. And what they're saying is that through 3D bioprinting, they can make a unique marbling, unique fat or muscle content, and you could even customize this. So a chef or a restaurant chain or you could even make a steak that's specific to you. Um, and that's a new thing. I don't know if it'll work, but I think anything to sustain their dream right now is a good thing. I mean, to me, what's more encouraging, the fact that we're working on a multi-nozzle modular 3D print head to print their steaks much more quickly. And of course, all these companies, they've raised an awful lot of money, but at the same time, they have the problem that they're using traditional bioprinting techniques that, from the print side to growing things in a vat, all the stuff that have not been industrialized. So their challenge is in sustaining the dream and getting enough investor cash to go to market with some kind of product until they can sustain and really industrialize a large scale thing or large scale production of this cultured meat. Um, to me, this can have a real outsized impact on our industry. And I think the mainstream 3D printing industry, mainly polymer and metal focus, doesn't really give these guys much attention. But they also need quality assurance services. They also need QMS systems. They also need nozzles. They need software, kind of like Octon type of functionality as well. They need design software and CAD for designing these meats, if you will. And this could be very niche, but a very, very highly impactful industry. So I think more people should be looking at what the 3D cultured meat and fish people are doing, because it could have a real huge impact. And yeah, it's something like we don't consider it part of the mainstream 3D printing industry, but we should really. The next news is the Edge E1 LCD 3D printer by Rayshape. This is a digital dentistry 3D printer. It's got a 4K mono LCD screen, 92, 120, 190 millimeter build volume. It's said to have a very high surface quality. And it's open, right? So it's an open printer. So this is a mid-market printer. So I'm following the dental space closely because we're seeing this emerge, and we're seeing chairside dental emerge, and we're seeing labs invest very heavily in 3D printing, like Glidewell and other labs invest very heavily in 3D printing. So what we're going to be seeing is essentially a slaughter. It's going to be a slaughter. It's going to be a really hyper-competitive space, and we've got like the traditional players, right? We've got 3D Systems, which is large machines. We've got EnvisionTech now in desktop mental health with its per-factory type systems, a Sega with kind of like $15,000 systems. Then we've got farm labs below that with custom resins and systems and kind of very integrated type of environment. We've got Star 3D and a Sprint Ray, which are, they kind of sell you everything you need from the software and from the materials and the printer to ease your adoption. And then we've got companies like this that are doing a different thing and saying, hey, you know what? We may make less margin on not selling you the material, but maybe you'll save a lot of money too. And then below that, we've got kind of like Elegoo Mars, So this is going to be especially this DLP SLA, this vat polymerization space in dental it's going to be a slaughter, really is. And I literally cannot tell you who will win in this. And it's going to pit some really large established companies against a lot of startups, and it's going to pit $200 printers against $300,000 printers. So it's going to be an incredibly engaging, incredibly exciting space for all of us to watch. McLaren has told us about its use of the RPS printers, or the Stratasys NEO 800 3D printers. These are large, very fast vat polymerization systems that we knew already that a lot of us have been hearing that a lot of Formula One teams have been using systems for years, which is why I was at least very enthusiastic when Stratasys bought RPS, because like we knew how well established they were and well entrenched they were in the Formula One world. Of course, the Formula One guys never talk about anything, so that's why it's nice that McLaren has disclosed that it has 5 NEO 800s, and is using them, which we kind of already knew, for a lot of wind tunnel testing, which is a lot of what the 3D printing guys, or the Formula One people 3D print. We even have special resins made for it, which is Somos Perform and Somos Perform Reflect, which is now also owned by Stratasys. The reason why they use these is that there's less post-processing, and then it's cheaper for them to make these like 60% scale kind of F1 car parts for the wind tunnel. McLaren has also disclosed that they make jigs, they make templates, and they make small mold components with this, and they make parts on the car. And McLaren's working with Stratasys or the RPS effect since 2017, and makes 9,000 parts a year. Which to me still, I mean, are they giving these machines a bit of a break, or I don't know, the components of these full-scale replica models of the race cars are quite large, but still, I don't know, maybe at least 9,000 parts a year is not that much. I'd expect them maybe to do more. That may just be me. Anyway, so, but it's nice to hear from them. The next is we're hearing from 3D Gents and Emery Oleochemicals, and they're partnering to be producing a bound metal 3D printing solution. I think it's a really smart partnership for both of them. So Emery makes a sintering system and has a lot of knowledge on the sintering and for MIM, and the MIM market generally, so they'll know all the customers, they know what they want. 3D Gents is a Polish high-tech, high-temperature FDM or material extrusion 3D printer provider. So them working together is, I think, very, very much a match made in heaven. And I think this is the right way to approach a market very quickly, with both taking each other's core knowledge and interest to heart in a partnership. 3D Gents has the Element MP260 and 350 MP350 printers on the market for this. And they're going to be selling them into the MIM market. And so a lot of people don't consider this bound metal to be real, competitive with powder bed or with binder jet, but you have to see it a bit differently. If you want really small, really detailed metal parts, you can look at slurry SLA, hollow AM, met shape, those kind of things, right? If you want parts a little bit bigger, you're going to be, and finely detailed, you're probably going to be wanting to look at binder jet, right? If you want parts bigger than that and cheap, then bound metal really makes sense. You won't have a lot of the detail or a lot of the capabilities you could put into some of these other parts, but the machines are going to be relatively inexpensive. The form factor of these things is going to be small, and the parts are going to be really low cost. Now, of course, I'm skeptical about binder jet and bound metal to making new parts all the time. I just think that's going to be too tedious, because every single time, until somebody figures this out, of course, the wall thickness, different geometry, and different size parts can give you different results and can cause different shrinkages and parts to warp and stuff like this. But if you're talking about, like, let's say, like a company that has a series of machines or quite large tools that you want to print out worldwide, and you're just going to take the trouble to qualify 1,000 parts and then be able to print them out cheaply in 10 different locations, then I think this bound metal is a really inexpensive, really interesting technology. And I think Mark IV is doing a lot on this. Ultimaker is doing it together with BASF, which of course wants to promote it because they're making these materials, and the NOA is doing it, and now 3D Gents, and I think more people will look at this. And I think this is a very exciting space to watch. 3D Systems has launched its CuNi30, or copper nickel 30 alloy. They did this together with Praxis and Huntington Ingalls, Newport News shipyard, which is kind of one of the largest producers of the U.S.'s warships. The material is going to be made available, qualified, and the parameters are going to be made for the DMP Flex 350 system, powder bed fusion system by 3D Systems. The exciting thing about this alloy is that it's a seawater corrosion resistant and the salt spatter kind of resistant alloy. So it's excellent for marine use, and especially for things like valve components, pumps, fittings, other kind of components that you might want to use on a marine ship. Not only that, you could use it as well, oil and gas, offshore industry, energy generally, like wind energy, those kind of things. So there's more uses for it, but I think the main use, especially with the Huntington Ingalls partnership, is defense. And I think this is a fantastic move by 3D Systems. The U.S. Navy's budget is, I think, 230 billion US dollars. And well, they want to put in another extra 100 ships on the sea. Now, part of the problem they have is that a lot of the U.S. Navy ships at any one time are being repaired. The UK Navy at one point had half of its fleet under repairs. Additionally, if you look at the repair times that the U.S. Navy takes to repair its ships, these are sometimes, the lead times vary, and they sometimes take months longer to repair these ships than need be or than they were told initially. And they only have so much capacity available in Singapore, Rota, and Bahrain to do this in the first place, as well as just the capacity they have in the States. So it's really costly for the United States to build new ships, and the more ships that they can't use because they're being repaired, the more they would have to build. If we're looking forward, if the United States was in an armed conflict and it would lose, let's say, 10 ships, or they would get damaged, it wouldn't have the capacity to repair ships, and it would take an inordinate amount of time to do so, limiting the actual naval force of the U.S. So this is like very important for them to be able to repair parts quickly. And there's a lot of money they would save to do this. And it actually kind of is a real concern to the Navy to be able to repair things faster. They would save a lot of money. They would make their sustainment efforts a lot easier. And they would have a much more battle-ready Navy if they could repair it quickly and repair it quickly if things would go wrong. So this is a huge benefit, especially since 3D Systems is a U.S. company, of course. Praxis is a subsidiary, but is a U.S. company, ostensibly anyway. As is Huntington Ingalls. So these kind of things, that would give a kind of warm blanket of comfort to the U.S. Navy, I think, to work with these partners. So I think it's a brilliant move. I really think that the potential here and the importance of this and the amount of money is quite considerable. And not enough people are paying attention to this, and just the marine industry generally. The next thing is that Mantle 3D printers are now commercially available. So Mantle is a startup we really like at 3dprint.com. We've met them, we've interviewed them for the 3D pod, we've studied them, and we really like this. So first off, Mantle is kind of like a binder jet paste extrusion system that at every layer they dry the layer, and then every 10 layers or so, dozen layers or so, they mill it as well. So it's kind of like if you would put a Sodic or a Matsura machine and combine it with binder jet or slurry binder kind of, or not a slurry binder jet, but kind of like a kind of paste binder jet. Now, obviously, this has the advantage that you have a kind of more solid green state part, which means that you could print some geometries that you couldn't print with other binder jet systems because the parts would just fall apart. Now, the other advantage here Mantle has is the fact that its system produces parts that are really well defined and are really sharp corners and really good detail. And that's really important for molding and tooling and that kind of thing, tooling inserts and stuff like this. And the thing I love about this most about this company is I like the management team, I like the startup, I like the technology. But the thing I love most is just the go-to market. It's just these guys saying, you know what? We're going to focus on tool steels, and we're going to have tool steels like H20 and stuff like this. And we're going to focus on tooling and tooling inserts, and that is our market. They could do a lot more stuff with this printer, but it just makes everything so much simpler. They don't have to talk to orthopedics people. They don't have to try to talk to, the guys in charge of Volkswagen. No. They just have to talk to every single tooling engineer, tooling manager, tooling person at every single large industrial company that makes molds, right? Or that needs molds. That's it. That's their universe. So it's much more limited. It's much more focused. Their marketing isn't going to be. They're going to have to do a white paper on aerospace, and next week a white paper on medical qualification. No. They're just super focused on this market. And I love the way in. It's just saying, hey, maybe you order a tooling insert from me, and I'll make it for you. or you try one, or we do a proof of concept, really simple. So it's not a 6 to 9 month kind of like engagement where you're trying to get these guys to change their production technology. You're just saying, you buy tooling inserts or tooling, I will sell one of them to you. You can try it, and then we'll get it to you cheaper and faster, and that'll accelerate your time to market. It's beautiful. I love this so much. And also, what I also like is now Mantle is selling these $350,000 machines, which of course will be bought by companies with a lot of tooling and a lot of tooling needs, right? But it's a really opportune time for them to be doing this. Right now, with the focus on supply chain resilience, and focus on making things nationally, especially in defense, trying to make all these things. Before, the one issue was that all the tooling engineers, all the tooling expertise is moving to China, or there already. There were companies that were losing the ability to make tooling themselves. And now it's a really opportune time to them to say, oh, wait, we want to make this kind of tooling, these mold inserts and these things in the US in order to have a shorter, less complicated, more localized supply chain, or a faster turnaround time on our models and stuff. So, and that is a really timely time to them to think, oh, wait, we can get one of these printers, or we could use a service with one of these printers to make these things faster. So I love this. I really, really love Mantle as a startup. And yeah, that was it for today, guys. And thank you so much.